everyone, I'm Teacher Justine and I'm here to discuss the sets and its notation. First, let us define what is set. A set is a well-defined collection of an element denoted by this symbol, or it is read as is an element of that shared a common characteristics. Other definition of set, it is a well-defined collection or group of object of an element, and when we hear the word well-defined, it in set and its notation, it means that it is possible to determine whether an object belongs to a given set. A set must be well-defined to avoid ambiguity about whether or not an object belongs to the set. So for us to understand well the set and its notation, let's have an example. For number 1 example, we have W is equal the cold months of the year. What is the meaning of this? Set W is not well defined. Yes, it is not well defined because we cannot say what are the cold months of the year due to the different countries and the climate changes that is happening today. Next one example, A is equal X by X, basketball players and volleyball players in grade 7 sunflowers. So what kind of set is this? It is well-defined or not well-defined? It is well-defined because you can now say who is the basketball players in the grade 7 sunflowers that is also a volleyball player. For us to remember the true definition of set, always remember that as you see on the examples, the elements of members or object of the set can be anything. Maybe it is a number, people, letters of an alphabet, and so on and so forth. So now let's have another example. T is equal the mango, coconut, and apple. This means that the set T contains the mango, coconut, apple, and so on and so forth. Meaning, all of the names of the word in the set T are all fruits, so it is a set or well-defined set. Another example, we have F is equal the thumb, index, middle, ring, and pinky. This means that the set F contains thumb, index, middle, rings, and pinky. So, it shows that all of the set F contains the names of the fingers. Now, let's consider the following set. Another example. Yes, the set of V and B as a boy. So, V contains the sets of Mayon, Taal, and Pinatubo. And B contains the set of Dove, Maya, and Parrot. To show the elements and not elements of this set, we have Mayon is an element of B. Yes, it is an element of B because Mayon is one of the name of the volcanoes. Next one is the Dove, is an element of B, or as in boy. Yes, it is an element of B because Dove is one of the name of the birds. Next one, Parrot is not an element of V. Yes, it is not an element of V because Parrot is in the set of B, which is boy. Next one is Taal is not an element of B. Yes, it is not an element of B because Taal is in the set of V, which is victory, that contains all of the names of the volcanoes. So for us to know and to remember what is set and its notation, always remember that a set which contains no element is called an empty or not set or null set and denoted by these symbols. So as you see in the screen, it is the symbols of empty or null set. The cardinality of a set is the number of elements in a given set. It is written as like this one. So where N refers to the cardinality and A is the total number of an element in the given set.
Good day, I am Ma'am Merryl Gumafelix and I'm assigned to discuss the roster form notation and how to use this properly. So let's get started. In roster notation, the elements of a set are represented in a row surrounded by curly brackets, and if the set contains more than one element, then every two elements are separated by commas. Let's say, for example, if A is the set of the first 10 natural numbers, so it can be represented by variable A is equals to open and close curly brackets 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is how simple we write the list of the first 10 natural numbers that are being asked. So, do you have any clarifications? Do you understand that?
Yes, ma'am.
Okay. So since this is just a simple method to use, let's try if you can follow the discussion by writing this into a raster form. So when I ask you to list down odd numbers from 1 to 20, can you write it in a raster form? Okay, very good. I'm glad that you all are following the discussion. So let's proceed now. One of the limitations of raster notation is that we cannot represent a large number of data in raster form. For example, if we want to represent the first 100 or 200 natural numbers in a set, then it is hard for us to represent this much data in a single row. This limitation can be overcome by representing data with the help of a dotted line or what we call ellipsis. For example, if any set has an infinite number of elements, like the set of all the even positive integers, it can be represented in roster form like this. Set B is equals to open and close curly brackets 2, 4, 6, 8, dotted lines, so on. Or set of even integers from 1 to 100 will be written like this. Set C is equals to open and close curly brackets 2, 4, 6, 8, ellipses up to 100. Another example, the set of alphabet from A to Z, set D is equals to open and close curly brackets A, B, C, D, ellipses up to Z. Do you understand that? Are there any clarifications with this? Okay, so now let's perform some examples. For example number one, what is the roster form of set A, the set of the first 20 natural numbers divisible by 5? So if I were to write this into a raster form, it would be like this. Set A is equals to open and close bracket 5, 10, 15, 20, 65, 70, 95 to 100. Or I can also write this as set A is equals to open and close curly brackets 5, 10, 15, 20, ellipses up to 100. The set identified in the problem consists of three criteria: natural numbers, divisible by 5, and the first 20. Natural numbers are also referred to as counting numbers and are any whole number greater than 1. So, numbers are divisible by 5 if the last digit in the ones place ends in a 0 or 5. This means the natural number can be divided by 5 and have no remainder. Finally, list the first 20 numbers that meet both criteria. So, for the second example, on the other hand, we have this. So, example number 2, consider the set C is equals to all integers that are greater than or equal to 20 and less than 20. Write this set in raster form. So, now it's your turn to answer this. Okay, very well said. We can now proceed to the next topic then, which is the set builder notation.
Okay, before we proceed to our next topic, I introduce myself. I am Sir JM, one of your teacher for today. Our next lesson will be set builder notation. Any idea? Okay, set builder notation is defined as a representation or a notation that can be used to describe a set that is defined by a logical formula that simplifies to be true for every element of the set. A set builder notation describe or define the element of a set instead of listing the element. Set builder form uses a statement or an expression to represent all the element of a set. In this method, we do not list the element. Instead, we will write the representative element using a variable followed by a vertical line or a colon, and write the general property of the same representative element. In set builder notation, you need to find the relationship of one to another to get the right answer for every question. Important note, we read the colon or the bar as such that, for example, the set 5, 6, 7, 8, 9 lists the element. We read the set x is a counting number between 4 and 10 as the set of all x such that x is a number greater than 4 and less than 10. Okay, another example. Can you write the given set in the set builder form? A is equals to 2, 4, 6, 8, 10, 12, 14. Anyone? The answer will be A is equals to x such that x is an even natural number less than 15. Therefore, A is equals to x such that x is an even natural number less than 15. That's correct, very good. Another example. How can I express the below given set in a set builder notation? B is equals to 10, 11, 13, 17, 19. Anyone? The answer will be B is equals to x such that x is a prime number and 10 is less than x and x is less than 20. That's correct, very good. That's all. Any clarification? If you don't have any clarification, wait for the next teacher to continue the discussion. Okay, thank you.
Good day everyone, I am Teacher Roselle and now let's proceed to our next topic, which is terms. Number 1 is finite set. Finite set, it contains exact number or countable number of elements. Example, A is equals the finger on your hand. The elements of set A are thumb, index, middle, ring, and pinky finger. Set A is a finite set since its elements are countable. Number 2 is finite set. It contains element that has no end. The ellipsis or the 3 dots means infinite or goes on or forever. Example, T is equal the group of mango, coconut, and apple. It is infinite or not? Yes, it is infinite set. And aside from the mango, coconut, and apple, there are more elements that belong in this set. Number 3 is subset. It is a set of elements that are also in another set. If there is at least one element found in B but not in A, then A is a proper subset of B denoted by AB. Set A is a subset of B if every element of set A belongs to set B. In the example number 1, if A is the set of 1, 2, 3, and 4, and B is the set of 1, 2, 3, and 4, and 5, then A subset to B, but B not subset to A. Since B contains elements not in A, we can say that A is a proper subset of B. Number 4 is equal set. It contains 2 or more sets that has exactly the same element. Example, if A equals to the group 2, 4, 6, and B is equal to the group 4, 6, and 2, then A is equals to B. Number 5 is equivalent set. Is 2 sets that has the same number of elements. Example, given A is equal to the group 1, 2, 3, and B is equal to the group A, B, C, then NA is equals to 3 and NB is equals to 3. Therefore, AB read is A congruent to B. And lastly is universal set. It is the totality of elements under consideration, and it is usually represented by U symbol. Example, let U is equals to the group of 1, 2, 3, 4, 5, 6, 7, 8, and 9. A is equals to the group 2, 4, 6, A. B is equal to the group 1, 3, 5, and 9. In the given sets above, set U is the universal sets. Sets A and B are subsets of the universal sets.
Hi, I'm Ibarrientos and I will discuss the subset of a set. First, let's define what subset is. A subset is a set of elements that also in another set and is denoted by this for proper subset and this if the subset is the set itself. If every member of set A is also a member of set B, then A is said to be subset of B. It is written as this, which is pronounced as A is contained in B or A is a subset of B. So for example, we have here set A, which are grade 7 Sampaguita students, set B, female students from grade 7 Sampaguita, and set C, tall students. In this set, we may conclude that set B is a subset of A since all the elements of set B is also belong to set A. In symbol, we have this, which is written as B is a subset of A. On the other hand, set C cannot be considered as a subset of set A nor set B since all the set of tall students is not a well-defined. Therefore, C is not a subset of A and C is not subset of B. So let's have another example. Tell whether the following set is a subset of A or not. Set A containing elements 1, 2, 3, 4, and 5. And set B containing elements 1, 2, 4. Students, does set B is a subset of A or not? If your answer is set B is a subset of set A, you're correct. B is a subset of set A since every element of set B is also in the element of set A. So, how about if set D containing elements 2, 4, 6? Does set D is a subset of A or not? Set D is not a subset of set A because one element of set D, which is 6, is not an element of set A. Just always remember, students, that a subset is a set that is within a given set. Now, let's determine the number of the subset in a set. For example, we have here set P containing elements Earth, Venus, and Mars. Subset of set P are empty set, Earth, Venus, Mars, Earth, Venus, Earth, Mars, Venus, Mars, Earth, Venus, Mars. Therefore, set P has 8 subsets. Note that this symbol is a symbol for therefore. In finding the number of subsets, we may use the formula S is equals to 2 raised to n, where n is a number of elements. So, for the given set P, S is equal to 2 raised to 3 since it has 3 elements which are Earth, Venus, and Mars. Let's have another example. If n is equals to 1, 2, then subsets are empty set, 1, 2, and 1, 2. Therefore, set n has 4 subsets. We may also use the formula S is equals to 2 raised to n. So, S is equals to 2 raised to 2 or 2 squared since set n has 2 elements which are 1 and 2. So, set n has a 4 subsets. Now, it's your turn. If set C containing elements red, blue, yellow, and green, determine the number of the subset of set C using the formula S is equals to 2 raised to n. So, what is your answer? If your answer is 16, you're correct. Since the number of elements is 4, substitute it to the given formula, so we have S is equals to 2 raised to 4. Therefore, set C has 16 subsets.
This is the last part of this video. So let's start. Hi student, I'm teacher Mikaela and I will discuss operation of set. In operation of set, we have 2 operations. It is union of set and intersection.
First, we have union of set. The set of all elements belong to set A or to set B or to both set is called union of two set, and it's denoted by symbol U. I give an example. Let's find the union of set A contains 1, 3, 5, and 7, and the set B contains 3, 4, 5, 6, 8, and 10. Then A union B, well, all that means that all the elements to set A and B combine into one set. So we got 1 in set A and 3 in both sets. But we write it one time. Next, 4 and also 5 has in both set. Then 6, 7, 8, and 10. Okay. A union B, well, that's all the element from set A and set B combined into one set. We got A union B equals 1, 3, 4, 5, 6, 7, 8, and 10. So that's the final answer. And remember, arrange in ascending form, smallest to the highest number, and the element should be not repeated. Next, we have intersection. The set of all distinct elements that are in both A and B, given two set A and B, the set of all elements belong into both set A and B is called the intersection. So basically, intersection, if you want to find intersection of two sets, it is the element that they have in common. So I give an example. Let's find intersection set A, 1, 3, 5, and 7. And set B is 3, 4, 5, 6, 8, and 10. Okay. In set A, we have 1, but B does not have 1. So we look to the next. In set A, we have 3, and also we have in set B. So there one element that they have in common. Next, we have 5. Well, also in B, we have 5. And the last is in set A, 7, number 7, but does have not in set B. So the only element that they have in common is 3 and 5. So this would be A intersection B equals 3 and 5. So that's the final answer. For additional information, if two sets had at least one common element, then the set are joint set. However, if two does not have a common element, then the set are called disjoint set. So we have an example. So this example, for you to understand the difference between joint and disjoint set. Okay, and in joint set, we have set 1, 2, 3. Another set is 1, 5, 6. They are joint set because they have in common the number 1. So next, the example for disjoint set. So we have set 1, 2, 3, and the next set is 7, 8, 9. They are disjoint set because their intersection is null. So when we say null, this is the empty set. That's all.